Welcome to the Nomad PHP Lightning Talks. I'm Joe Ferguson. If you'd like to give a 10-minute lightning talk, please email me, joe@nomadphp.com. Right now we have Christopher Pitt, and he's going to be talking about zombies and binary. Please make sure you visit Joined In after the talk and leave Christopher some feedback. Christopher, go ahead and start the screen share. All right, take it away.
Thanks, Joe. Right, so as PHP developers, we use binary every day. We may not be doing it with strange bitwise operators and low-level code, but every time we write an if statement or a while loop, what we're essentially doing is binary comparison. So let's look at an example of this. If we drop down into the PHP interactive shell, we can see the simplest of if statements. If true, print success. So what this does is that the if statement, or the compiler more accurately, evaluates everything within the brackets, and if it evaluates to true, the body of code immediately following will run. That's why we see success. We can, of course, combine multiple expressions with an AND statement, and that will evaluate all of the expressions on either side of AND, and if they become true, then the body of code will be run. In this case, we don't see anything. And that's because AND wants both sides of it to be true. In addition to this, there's also an OR keyword, which will look along a list of expressions and return true for the total expression at the first true value it sees. So if true or false, well, it sees true initially, and it will print success. This is order independent. The interpreter will just keep on going until it finds a true value. If it doesn't, it won't run it. But in this case, it finds true eventually, so print success. Now, we usually work with more complex examples than this, so let's look at just substituting variables in place of those Boolean values. In this case, we'll assign true, false, and true to these three variables and put them in a more compound expression. Well, when we run this, we don't see anything again, and that's because, if you'll remember, $true is set to false. So AND is going to look for true on both sides, it sees $true as false, and the whole expression becomes false. In this case, what we can do to remedy it is we can invert $2. So inverting basically says if it's true, make it false, and if it's false, make it true. Then, because $2 was false, the inversion says, okay, this now becomes true. So if 1 and 2 and 3, all of them now seem true, then print success. Success, right. So this is basics of what we do every day as PHP developers. But let's look at how it interacts with zombies. This is Minecraft. It's an open-world sandbox game developed by Mojang and Marcus Pearson, recently sold to Microsoft for $2.5 billion. It's a pretty big deal, and I guess that makes this my first Microsoft tech stack talk. Well, it's about mining. So you can go underground and you can mine with tools, important minerals and resources. Of course, you can take those above ground and after punching some trees also get some wood, combine these things into armor and tools and more building materials so that you can basically survive. And all of this happens during the daytime because at nighttime, well, then the baddies spawn. So you can see skeletons in the game, you can see zombies in the game, and creepers. Now, I've entitled this Zombies in Binary, not because it features many zombies, but because it's the kind of logic that we can do in Minecraft. The kind of programming that we can do every day in PHP translates into Minecraft in such a way that even zombies would be able to see the correlation. But the bits of Minecraft that are important to us, well, there are a few components, so let's look at what they are. First off, there's a switch. Now, this is an on-off state, and when it's on, it acts as a power source, so it sends a charge out, it emits a charge. It can emit that along what's called redstone. Now, redstone is a block that you can find underground, and when you break it, it drops a bit of powder. That powder can be laid in lines on the floor so that it becomes a kind of conductive trace, similar to what you would find on the underside of circuit boards. You know the silvery lines that conduct charge? Well, that's what redstone is. And this is what it looks like when it's conducting that charge, so it lights up a bit. Next up, there are redstone lamps. So these resemble light bulbs or LEDs. When they get a charge, they turn on. So they work as really good feedback for any circuitry that we do in Minecraft. Then there's a repeater. Now, Minecraft has this repeater because redstone has an attenuation. So if a charge traveling along redstone goes past a certain distance, it loses charge. Repeaters will take this kind of situation with signal attenuation, and they will re-amplify the signal, which is pretty useful for bigger circuitry. Then there's a redstone torch. Now, redstone torches are similar to switches in that they are power sources, but they are always on, and they can't be turned off by physically interacting with them. They can only be turned off by another charge flowing into them. And this is what that looks like. So this redstone torch has a charge flowing into it, and it turns off. Now, using this mechanic of redstone conducting charge and redstone torches turning off when they get charges into them, we can make AND gates. So seeing input 1 and 2, they're both off, which means the redstone torches on top of that raised section of dirt, well, they're allowed to turn on, which means the redstone between them is on, which means the torch in front is off. Basically, when both inputs are on, the output is on. And obviously, when both inputs are off or only one of them is on, the output's off. This is an example of an OR gate. It's a lot simpler than an AND gate. It basically just turns on if there's a signal from either of the inputs. So input 1 and 2, you can see input 1 is on, and if either input is on, the output is on. And this we saw a little bit of in the AND gate, but this is a basic inverter. So this is, remember, we turned $2 from false into true using an exclamation mark. This simulates that effect. So when the input is off, the output is on. And when the input is on, the output is off. Now, putting these three simple concepts together, we can make circuits like this. That's pretty cool. And we'll look at just one of the conditional branches of the circuit so that you can get a kind of feel for what it would be like if we were writing this in PHP. Let's start off down here, where all the switches are off, which means all of the signals are false. By the time it gets to the first branch of the circuit, we can think of it as if $1 is false, $2 is false, and $3 is false. We immediately invert all of those, so now they're all true, and then we get to our first conditional expression. Condition 1 is equal to $1 and $2. Now they're both true at this point, so condition 1 is equal to true. Our second conditional expression, $3 and condition 1, well, condition 2 is now also going to be true because $3 is true and condition 1 is true. And if condition 2 is true, the light goes on. What? Minecraft allows us to model the logic flow by binary comparison. It also helps us to think visually about how control flow works. It doesn't implement concepts like voltage, current, and resistance. So if you're coming from an electronics background and you work a lot with those concepts, it's not that easy in Minecraft. It's very simplified in Minecraft. And nor does it make variable storage easy. We'll see examples later on of how people overcome that. But you've got to do a bit of work. It's not as easy as what my explanation makes it seem. So how does this cross over? I do some robotic stuff, and one of the components that I work with frequently is called a multiplexer. It looks like this. The multiplexer accepts one input charge, and it has 3 binary selection pins. And based on the on or off state of all 3 of those binary selection pins, it's going to take the one input charge and route it to one of 8 outputs. So if all of them are off, the output channel is going to be 0. If all of them are on, the output channel is going to be 7. And various combinations will select a channel within that. Does that sound familiar? It's this. This is a Minecraft simulation of the internals of the multiplexer chip. So each of these 8 channels maps to one of those 8 outputs of the multiplexer chip. And each of the 3 switches at the bottom maps to the 3 binary inputs that this chip gets. This is the internals of that chip in Minecraft. Let's look at a more complex example. I mean, what we've seen so far is pretty simplistic. This is called the Commodore 32. And if you're familiar with the Commodore 64, this is a simplified version of it, which implements functionality available in the Commodore 64 in Minecraft. So it's a Minecraft map that you download, and then you can use it like a computer. It's got things like this GPU, which deal with its triple buffering. It's also got a processing core and memory, and that gives it the capability to have a 32 by 32 pixel 16 color screen, and essentially 16-bit color. It's got a 32-bit processor architecture. you can see this at that link at the bottom. And not only can you download the map and try its example applications, which the first one that installs is Logo or Turtle. It's a drawing application. You can also download other applications like Tic-Tac-Toe. Not only can you download those sample applications, but you can download an SDK, which will let you write code for this map in a high-level language and then transfer it into the memory buffer of the Minecraft map so you can run your own programs with it, which is pretty awesome. Well, that's all I've got to show you today. Be sure to follow me on Twitter if you want to see more fun stuff like this, because I post about it regularly. And if you've got some time, leave me some feedback on the joined in link there. And the last link is to a series of articles that I'm going to write an expanded version of this talk so you can get to more of the detail of it and see some more electronics examples. Cool, thanks.
All right, thanks for joining us for another Nomad PHP Lightning Talk. If you'd like to give a Lightning Talk, please email me, joe@nomadphp.com. Please make sure you visit Joined In and leave Christopher some feedback.